Hi, I'm Thomas Hunter, and welcome to my talk, GitHub Actions for Node Apps. And the content from this talk is based on a book I recently published called Distributed Systems with Node. All right, let's dive into it. So first, we're going to look at an overview of GitHub Actions. So you might be wondering, what is a GitHub action? Well, it's a way to run continuous integration tasks related to your code base. And it's actually super convenient if your code already happens to be hosted on GitHub, which most repositories these days seem to be. The way it works is it ultimately allocates a virtual machine for you somewhere and then runs a bunch of code for you once a GitHub action has been triggered. And so as far as billing goes, it ends up being based on minutes. And so if you have a free account, you get 2,000 minutes per month. A pro account, 3,000 minutes per month. And then if you have paid accounts, you can, you get different tiers and you can pay for them as well. And so this provides continuous integration that's defined using code. And so these GitHub actions, they end up being defined using YAML files that are checked into the repository. And so they're going to live in the .github directory inside a folder called workflows. And then you can end up creating multiple YAML files for each different workflow that you want to define. So they end up getting committed, they're versioned, checked in. You can make pull requests, sort of verify and review that they look good. And honestly, if you're using a system like Travis CI or Circle CI, this approach isn't going to be all that different. One thing that's nice, though, is you don't have to create a new account. You don't have to, authorize it, configure them, and all that stuff. Since everything lives under the GitHub house or roof, it all ends up working together pretty seamlessly. One nice quality about these workflows is that they're composable. And so a workflow ends up being made of one or more jobs, and then a job is made of one or more steps. These different jobs, they end up running on different virtual machines. You can specify dependencies. You can say that this job depends on that other job. And so by defining them that way, you can actually build out some sort of like dependency graph and run code in parallel. And the individual steps, those end up getting run sequentially. And so those steps can actually refer to external GitHub repositories. And so for example, this uses line here, that represents code that you would see within one of these workflow files. And so this is saying that it's using actions/setup-node at v2.1.4. And so that actually ends up translating to a GitHub repository. In this case, it's the actions organization, which is maintained by GitHub, and then the setup node repository in that. And then that @ symbol there, that actually references a tag. And so this is saying that we want to use the v2.1.4 tag. Another thing you can do is define configuration used by these workflows. And then that configuration ends up sitting inside the project settings. And that configuration is called a secret. And those secrets are sort of kept from the eyes of those who shouldn't necessarily see it. But essentially, it's a way to just set key value pairs that you can use within your workflows. And so one thing that you should consider doing if you adopt GitHub Actions is to then create actions for common organization patterns. So for example, if your company has perhaps like a dozen node repos and they all end up deploying microservices within your infrastructure, it would then make sense to create GitHub actions that you can then share amongst all those projects. All right, now let's look at an example workflow. This is one that we're going to use for a pull request. And so much like the other CI solutions, if you've used them, is that the output for these end up being contextual within the pull request. So in this case, we can see that there's this poorly crafted pull request with no description, but we can see at the bottom that the results of the workflow have been published. So they're very convenient to see contextually within a pull request. And so let's actually look at a workflow file. And so this represents a bit of boilerplate, which you'll need to use within these different workflows, but it's not too bad. In this case, we have a workflow called prlinttest.yaml. So the first thing we do is define a name. So this will be displayed in the GitHub user interface. So in this case, the name is linter and acceptance tests. We then have this on clause here, which specifies essentially the trigger for executing this workflow. And so what this is saying that is when a pull request is made against the main branch, that it should kick off this workflow. You also notice that sort of dangling field there called workflow dispatch. And so by providing that, you're able to then manually trigger this workflow as well using the user interface. After that, we have this jobs clause. And inside there, we have a build job defined. And so we're saying that that job is going to run on the latest Ubuntu image. And so, yeah, these end up living inside of a virtual machine. And so this is going to run within a virtual machine with Ubuntu installed. And so that build step or job is then made up of individual steps. And so the first step here is that the code ends up getting checked out. And so a lot of the workflows that you'll write will probably begin with this step to check out the code, though not necessarily all of them. So in this case, we're using the checkout action in the official actions organization, and we're using a floating tag called v2. All right, so here's some additional steps as well. So the first thing we want to do is set up the node environment. And so this is using another GitHub action called setup node. And then you can see that we have an additional property here called with. So that's a way that we can provide sort of arguments to these steps. So in this case, there's an argument that step accepts called node version. And as you might have guessed, that represents the version of Node that we want to get installed. In this case, the latest LTS. And so this action provides like the node binary. It's probably also providing like npm, yarn, and some other niceties that are probably applicable to a Node application. After that, we're actually going to install the dependencies. And so we're going to run npm install. In this case, there is no uses clause. It's just using the run clause. And so what that means is that we don't need to use like an external action dependency for this. Instead, just execute the following shell command. And again, we're going to do a similar pattern with the linter. And so this is how we run a linter. This assumes that we already have a lint script defined in our package.json file. So at the bottom, you can see a screenshot of the step. And so each one of the steps, they end up executing, and you get to see the output. And then you can expand them. And then so here we see that the linting process took about 1 second, and we're able to see the output from the command. And so standard out, standard error, that's going to get displayed here so that you can view it and then debug a failing action. So here's another one that's probably applicable to a lot of projects. And this is going to, build a Docker container. And so the name of the step is build and start Docker containers. And so it's using the Docker compose command. And so the GitHub workflow virtual machines, they provide just a bunch of convenient tools. One of them happens to be a Docker. And so here we're running Docker compose. We're referencing the Docker compose YAML file, which is checked into the project. And so we're saying that the up flags is stating that we want the Docker containers to run. And then the -d flag states that we want it to daemonize and fork to the background. So once the containers are then run, it then goes to the background, and the next step continues. So in this case, we're running npm test, specifying a environment variable that points to the application. And so here, the Docker compose YAML file has been configured to listen on port 1337. And then so we provide that hostname and port to this particular test suite. At the bottom is a screenshot of the step. Once it's complete, we can see that 110 tests passed within 1 second. And if we were to scroll up, we would see the output from each individual test. So here's what the full workflow output looks like. So within a pull request, you can click it to get more information. So here we see we have the linter and acceptance test workflow. We have the build job has been selected, and then each individual step is displayed on the right. All right, now let's look at another workflow. This is a workflow that's going to represent when our pull request gets merged into the main branch. So again, we have a bit of boilerplate. In this case, we have a new workflow file. This one's called main-deploy.yaml. And again, it has a name, in this case, deploy to production. The on field is a little bit different. And so this is saying that when a push happens to the main branch, that's when we want to trigger this workflow. And again, I have the workflow dispatch field in here so that we can manually execute the code. All right, and so down here in jobs, we have first we have a build job. So again, this is saying that it wants to run on Ubuntu latest. And then the first step here, again, is to check out the code. All right, so now we have some additional steps. And so this one here, we want to set up the Docker environment. So this is using a repository provided by the Docker company. And then we want to build the container and push it to the registry. And so we're using another repository provided by the Docker company. This one has a bit more complex configuration setup. And so the first thing we're doing is providing the context, and that represents the path to essentially the root of the file system where we want the Docker container to get built. We also have this push true flag that's saying that we want to actually push it to the remote server. And then finally, we have some tags defined. And so this is using a multi-line YAML string. And so these tags here, these are the full verbose, long tag names. But here we're saying that the first tag is for registry.foo.com/x/y, admittedly horrible tag names. And then finally, the most important part, though, is after that colon. So we're saying that when we build this, we want it to both be the latest tag, and we also want to specify a more specific tag for this particular build. So in this case, the name of the second tab or tag is SHA, then a hyphen, then the actual SHA name of the code at the point in time that we checked it out to run this code. And so notice how there's that $sign and then the double curlies, and then GitHub.sha. So that syntax there allows us to inject variables into these scripts. And so there's a bunch of different variables that you can get from different sources, but one of them happens to be the actual GitHub hash. And so that's provided as GitHub.sha. And so by tagging this with latest, we're able to then, pull this image, referencing it as latest, but then by also tagging it with a SHA, we're able to actually refer to it later and sort of, post-mortem, refer back to previous releases. All right, so now let's look at the actual deployment. And so here we have a second job defined for this workflow. The name of this job is deploy. And so here we have the needs field set to build. And so what that's saying is that this deploy job needs to run after the build job has completed. We're also specifying that this runs on Ubuntu latest again. And then here we only have a single step. And so this step here is to deploy the application to a VPS. And so this is going to represent sort of a poor man's deployment process. And so this one, it's pretty simple. We're just going to use SSH to execute some commands on a remote server. But of course, you could build out a more complex integration using something like Kubernetes, for example. So in this case, we're using a third-party step. So this is by someone named Appleboy. And then we're using their SSH action repository using a very specific tag name. And then this, again, accepts some configuration. So we're passing in the host, the username, and the key. And then so these end up pulling the data from the secrets collection for this project. And so again, we're using the dollar double curlies, but this time we're using secrets dot and then the name of the secret. And so for this project, there are 3 secrets defined: the SSH host, SSH user, SSH key, and then those are then pulled in and then passed into this project here. And so you wouldn't really want to configure these connection settings within your YAML file, because then you'd have to check in potentially confidential information into your repository. So here's the final part of that deployment job. And so here we actually specify the script that's going to run on the remote server. So what this is saying is that the first thing we'll do on the server is pull the Docker image from the server, or from the remote registry. And then we'll stop the application, which would throw an error normally if the application wasn't running. So we just tack on that or true. We also remove the application, again, continuing if it fails. And then finally, we run the application again. And so here we're running docker run -d. So this is going to daemonize the process to run in the background. Otherwise, the command would hang. We're also going to pass in an environment variable. So this shows how you can take some of these secrets and then inject them into your actual application code. So in this case, there's a secret called sum value, and then that's getting assigned to an environment variable called sum value, and then passed into the container. Here, the name of the application is also set to my app, which is the same application that we had stopped previously. And then we're specifying that we're running the latest version of the application. And finally, we're saying that within the container, execute the node binary using the specific entry point. And so there's a bit of a shortcoming with this approach, in that you're going to have some downtime as you stop and start the application. So this is definitely not something you would necessarily use in production, but it should give you a feel for the power that you have available to you using GitHub Actions. So I mentioned earlier that the workflows are dispatchable if you have that workflow dispatch field available in your YAML file. And so within the project, if you do have that defined, you can go to the Actions tab. And then here on the right side, there's this Run Workflow dropdown. So you can click that. You can configure the workflow and then click Run Workflow, and it will execute the code. So by default, it allows you to select the branch, but you can actually configure the YAML file to have other inputs as well. So for example, maybe you have a workflow that represents deployment. And so you could, for example, define like a target for the deployment, like maybe you want to deploy to production versus staging. And so you could then define those inputs in your YAML file. And then here within this dropdown, you could then enter those inputs in and then click Run Workflow to actually execute the code with the correct target in mind. All right, so finally, let's take a look at some of these GitHub Actions. And so as a nice little bonus, these GitHub Actions, they can actually be defined using Node. And so the official GitHub Actions orgs provides us an example repository that we're going to look at now. And the name of this repository is Hello World JavaScript Action. And so I took the code from that for this presentation, but then cleaned it up a little bit so that it would fit within the slides. So this isn't exactly what you would find within the repository. So a GitHub Action repository, it needs a few things. One of them is a file called action.yaml. And so within this file, first you do a bit of describing the action. So here we have a name and a description for the action. You can also specify the inputs. And then so these correlate to the with entries in that YAML file. And so here we're saying that there's a single input defined called whom. And then the description of the whom is who to greet. This input is not required, so it's set to false. And then a default value of world is supplied. We can also specify outputs. And so in this case, we have a single output defined called time. And then so that time field will represent the time that this code gets executed. So you can use these inputs and outputs to sort of chain values between these different steps within your build process. And finally, we're saying the environment that this runs in. So this is going to run on using Node 12, and the entry point is going to be index.js. And so this is what index.js looks like. So this requires two packages. Both of them are provided in the npm org add actions. And so the first one is core, and the second is GitHub. And these allow us to interact with the GitHub Actions API in a convenient manner. So the code here is getting wrapped in a try catch. So the first thing we're going to do is grab one of the input values. And so here we're grabbing core.getInput, where we're looking for the whom value. And then we're assigning that to a variable titled name to greet. And then we're just going to log that. And so we're going to call console log with that value. And then the output that we print to the log ends up getting displayed in the output for the action. After that, we're just going to generate the current time and then assign it to an output. So core.setOutput, passing in the name and the value. And there's also a bunch of data available at github.context.payload, which represents the action that's being executed. In this case, we're not actually doing anything with it, but just keep in mind that it's there. And finally, we're wrapping everything with this catch. And so we catch the error, and then we're going to call core.setFailed, passing in the error message string upon failure. And so this will allow us to fail the whole task and then provide some information to the user as well. And so this is how you can actually use these values. And so this represents like a truncated version of one of these workflow files. And so here we've got this hello world step. The job is called hello world. And then the first step here runs that hello world action. So here we can see that we're using that GitHub repo. We're using this name field, which says that this step is going to be called hello. And then we're also using the with thing so that we can provide the whom value. And then after that, we have another step that runs. And the second step is just going to echo the output, just sort of showing how you can use that value. And so here we're calling steps.hello.outputs.time, and we're able to then use that variable that we had outputted from the previous step. All right, well, that's the talk. Thanks for watching. Feel free to follow me on Twitter at @TLHunter. And this presentation is available online as well.